All right, here I can show you if not. So let's say that I got these two windows here that I want to have them split screen so I can see both of them. For most of your Chromebooks and even your laptops, if you drag them over to the side, to the right side, it'll pop it on the right. If you drag it on the left side, it'll pop it on the left. So you can have both windows up, right, if that helps you with taking notes and watching the Zoom at the same time. All right, so here we go. Introduction to relations and functions. So to kind of start out, I want to go back and review what you know about the coordinate plane and its properties. All right, so the coordinate plane, you see it here, right? You got your two axes that divide your coordinate plane into 4 different quadrants. My axis here that runs horizontally, what axis is that? Which one? The X. This is the X axis. Wait, that dash went the wrong spot. Let's try that again. There we go. So then that means the vertical axis is which one? This is the X, is the horizontal. This one is? What's this one? Got X axis and the Y axis. We got our X axis and our Y axis. Now where these two axes intersect, all right, this is a special point. What is it called? The origin. And what, it had an ordered pair that went with it. What is it? Say that again. I can't hear you. Oh yeah, what are the coordinates? What are they? Do you remember? 0, 0. All right, so that point where my two axes meet is my origin, and that's at the ordered pair of the coordinates 0, 0. So we said that these axes divide it into 4 quadrants, and I want to talk about what were the names of those different quadrants, and then also in that quadrant, what is X and Y? Are they positive or are they negative? So we start over here in this top right-hand corner, and that is our quadrant 1. And in quadrant 1, what are the X's? Positive or negative? They're positive. X is positive. Right. What about the Y's? I can't spell today. Y is also positive. So in quadrant 1, X and Y are both positive. Right. Now we gotta have quadrant 2. The question is, do I go down or do I go to the side to get quadrant 2? Do you remember? Which one? To the side, yes. This is quadrant 2. Quadrant 2. And in quadrant 2, X is what? Negative. And Y is positive. They're probably just cleaning it, yeah. I have to get used to that. It's so strange. All right, then where do we go for quadrant 3? Bottom left, yep, right here. This is quadrant 3. Yep, and in quadrant 3, both are negative. Oops, except for you got to type negative. And y is negative. And so then that leaves us over here. This has to be quadrant 4. And in quadrant 4, x is positive. And y is negative. All right, and last thing here to talk about with the coordinate plane is we have all these points on the coordinate plane that we write as an ordered pair, and they're going to have an x and they're going to have a y. Can you tell me which one comes first, the x or the y? The x. So in an ordered pair, it's going to be the x, then the y. The x coordinate, then the y coordinate. Say that again. Yep. And we're going to do that some today. All right, so let's go to the next slide here. So we're going to talk about, now that we've kind of refreshed our brains on what the coordinate plane looks like, now we want to talk about the meat of today's lesson, which is relations and functions. So I'm going to start here with a definition for a relation. And a relation is a set of ordered pairs. A set of ordered pairs is a relation. Right, and then we've got 4 ways in which we can represent a relation. They can give you the ordered pairs, they can put them in a table, they can put them on a graph, or they can create what we call a mapping. So let's come up with some ordered pairs to make our relation. If we look at my graph, it looks like I can only go up to like 6. So somewhere between -6 and 6. Give me an ordered pair. Anything you want. Say that again. 4 and 4. Okay, I'm good with that. Let's get another one. Another ordered pair. Say 2 and 3. 8. All right, 8 I don't think is going to fit on my graph here. Let's take it down to 6. We'll do 2 and 6. How about some negatives? -2 and 4. Okay, and let's go one more. How about 3 and 0? All right, so there's our ordered pairs. That's one way they could give us our problem. They could take those same ordered pairs and they could list them in this table here. So let's do that. So 4 and 4, 2 and 6, -2 and 4, and 3 and 0. All right, we could create a graph with those same points. So you can see here, I've already made some points for you. So you just got to pick them up and put them on the graph. So we got it 4, 4. Let's see. 4, 4. There's 1. Right. It's kind of easier. I'll tell you what I'm doing. I clicked on the point and then I'm using my arrows to move it around. That makes it a little bit easier. Then we got to go for 2 and 6. Let's see. So we go over 2 here. Then I'm going to go up to 6. And I'm going to select my next one is at -2, 4. So let's see here, a -2 and then up to 4. Hit Control Z and Z. That's undo, in case you didn't know. All right, and then 3 and 0. So 3 and 0. There we go. So there's my graph. Okay, and now let's create a mapping. So mapping is the last representation. Y'all need some more time to fix your points? Okay, I'll pause. We're good to go? Okay, so now let's create that mapping. So mapping has 2 ovals, as you can see here. I've already created for you. And then in one oval, you put all your X's, and in the other one, you're going to put your Y's. Now, the key thing, though, is if you have an X or a Y that repeats itself, you don't put it twice. You only put it one time. You also need to do it where you go from least to greatest as far as in your order when you list them. So on this oval here on the left-hand side, I'm going to put my X's in this oval. So these are my X's. All right, and I want to go from least to greatest. So what's my smallest X? -2. So -2. Then what's my next one? 2. And then 3. And then 4. I'm going to try to put some spaces here. Let's see. Oh, that's not going to work. Let's do this. Let me see. If I highlight them and I'm going to change my line spacing. All right. I think that worked pretty good. All right, so there's my X's. Now I'm gonna come do my Y's. So I got my Y's. I gotta go least to greatest. 0, and then 4 and 6. Right, so I have 2 4s, but I don't list them both. I only list it one time. All right, and again, I'm gonna, why is that? Because you're gonna use the arrows to show what goes with what. Yep. So you can have an arrow going, or like going to a number twice. All right, let me change. I want to change my spacing again. There we go. Makes it a little bit easier to read. So now I've got these arrows up here, and I'm going to use my arrows to connect the numbers that go together. So for -2, what does it go to? -2 goes to 4. So here's my arrow. I'm going to put it next to -2. And I'm going to grab the end of it and make it point to to 4. Okay, for the next one, I'm going to grab another arrow. I've got 2. What does 2 go to? 6. So put our arrow next to 6, or excuse me, next to 2. Come over here next to 2. And then grab the end of it, and we're going to point to 6. Okay, and then we've got 3. What does 3 go to? 0. So we'll put our arrow here next to 3, and then drag it up and point it at 0. What did 4 go to? 4. So my last arrow we'll put here next to 4 and point it also at 4 in the Y column. And so there is my mapping, showing how each X goes to each Y. Any questions on any of those mappings? And so we can do ordered pairs, a table, a graph, a mapping. Okay, we ready to move to the next slide? Okay, so let's move to the next one. All right, so with a relation, we like to talk about some of its key features, and one of that being domain. So do you remember what is the domain? What did that go to? Domain of a function or a relation, I'm talking about what? We've been talking about ordered pairs, right? So it's got to be either the X or the Y. Which one was the domain? The X's. So this domain will be the X values in a relation. So then that means our Y, or excuse me, our range is our Y values in our relation. And so let's list out the domain that we had for that example we just came up with on that previous slide. So domain, usually we write these in the curly bracket. So what were those X values in our problem that we just had? What, -2, 2, 3, and 4? So those are our domain values. Those were our X's. And then our range. What did we have? 0. Can't remember. 4 and 6. Is that it? Yep, 0, 4, 6. So 0, 4, 6. So those were our range values for that problem that we just did. All right, so I got a couple of sentences here we're going to fill in talking about relations. So we say when each value of the domain, I think this blank is supposed to be here. Because I don't think the word here, let's go, I think this is supposed to be the domain in the blank. Let me fix it. Domain, there we go. So when each value of the domain of a relation is paired with exactly one value in the range. So one domain goes to one range, then that relation is known as a function. Each value of the domain is paired with exactly one value in the range. The relation is known as a function. To determine if the graph of a relation is a function, so this is talking about the graph, we use the vertical line test. To determine if the graph of a relation is a function, we use the vertical line test. For a list or a table or a mapping, so a list, a table, or a mapping, to be a function, the same X value cannot be paired with more than one Y value. And so basically what that's saying is you can't have an X value that goes to two different Y values. The same X cannot go to two different Y values and it be a function. So from a graph, we use the vertical line test. But from a list, a table, or a mapping, we're looking, do I have the same X that goes to two different Ys? If I do, then that's not a function. All right, so here we got some examples. So we want to identify whether the relation is a function, then state the domain and range. All right, so I put these little circles up here so you can drag and drop that circle over whether we say yes or we say no for a function. So for the first one, all right, we got a table. So we're looking, do we have the same X value in that table? Do you see an X that repeats itself? Got -7, -4, 2, and 5. Any of those the same? No. So if none of those are the same, then I think that means that it can't be that case where it's not a function. So it must mean that, yes, this is a function because I don't have any X values that repeat. I'm looking for X values that repeat themselves or go to two different Ys for it not to be a function. And that is not the case here. All of my X's are different. All right, let's list out the domain. So I got -7, -4, 2, and 5. All right, let's list out our range, our Y values. Let's go least to greatest. What's the smallest of those Y values? -3, and then -1, and 0, and then that leaves 9. All right, looking at B. Do I have an X that repeats itself? Look at your X's only. So -5, 0, -2, 0. Oh, I got 2 zeros. Do those 2 zeros have different Y's? Yes. So if I have the same X to 2 different Y's, is it a function? No. The same X to 2 different Y's is not a function. Same X to 2 different Y's is not a function. Right, so just because it is not a function doesn't mean that we can't talk about the domain and range. Right, we still can do that. So what are my domain values for this relation? What, -5, -2, and 0. And then my range values, 2, 5, 7, and 9. X's domain, range, Y's. Yeah. I was just giving a reason why. Okay, looking at C. Is C a function? Well, we think it's yes. Well, it looks like to me, if I'm looking at my arrows, -2 is going to 16 and it's going to -8, right? So that would mean a same X value is going to 2 different Y values. And if I have that, then it means it's what? Not a function. Yep. The same X going to 2 different Y's makes it not a function. Okay, we can still list out our domains. All right, a mapping makes it really easy for us because they already separate them. So my domain is an X, or my X's are -2, 0, and 2. And my range, -8, 0, 8, and 16. Any questions on those three? All right, let's go to the next slide. So these are having us look at graphs. And looking at a graph using the vertical line test to determine is it a function or not. All right, so what I did here is I created some lines for you to use. So I created you some vertical lines. All right, so again, I'm going to click on it. I'm going to use my arrow keys to help me move it around. So what I'm looking for is if I take this vertical line and I move it across the graph, does that vertical line ever touch any part of my function twice at the same time? If it touches that function twice at the same time, or excuse me, that relation twice at the same time, that's not a function. So I'm got my vertical line here selected. Like I said, I'm using my arrow keys. I'm going to take it across. You tell me, does it ever hit that line twice at the same time? Did it ever happen? I can move it back. No. So is that function or not a function? That's a function. All right, let's take our next one. All right, so I'm looking, if I take this vertical line, I move it across, does it ever touch that blue line twice at the same time? No. I'm looking at the blue line. Does it ever hit the right here, this line? Does my vertical line ever touch it twice at the same time? No. So what does that mean? Function or not a function? Function. That's the X and Y axis though. I'm looking at, does it touch this line here? For A, so we'll go back to it. So does this vertical line ever touch that black line twice at the same time? It would or would not? Well, this one is slanted. Oh, you're talking about this? Right, but then if that's the case, then it wouldn't be a vertical line. And this is what we're using as a vertical line test. All right, let's take this next one. I take my red line here, I move it across. Right there. Once I get right on top of that function, it's touching it twice. It is touching it twice. So that means that it is not a function. Okay, here's my next slide. We got a few more to look at graph-wise. So I'm going to click on my vertical line. I'm going to take it across. You tell me if I hit that graph twice at the same time. Did it? Did my vertical line ever hit that graph twice at the same time? No. So that means it is function or not a function? Function. Okay, going to E. Grab my vertical line. I'm going to move it across. Look, what's happening? Is it hitting it twice? Yeah, right there. Right, it's hitting it here and it's hitting it here. So what does that mean? Not a function. And that vertical line is hitting that curve twice at the same time. Okay, I think this is our last one here. So we take our vertical line across. Do you tell me? Well, we might have some more. I can't remember. Is it ever hitting that function or that graph twice? No. So what does that mean? Function. Okay. All right, you try these three. Decide which ones are functions or not a function for the last three, G, H, and I. Just wait. I'm giving everybody a chance to do them. We can go over them. All right, so looked at G. What'd you get? It's what? Not a function, right. So if I stop my vertical line right there, I can see it's hitting it 3 times, and that makes it not a function. Okay, what about H? What we function? H is a function because I take it all the way across and it never hits twice. And I, function as well, yep. So if I get over here, I'm never hitting this curve twice at the same time. You may have thought right in here it was, but there is a slight little curve to it there.